For this problem, we're going to do an RL circuit with AC input signal. All right, so we are given that our signal Vs of t is 15 sine 4 times 10 to the fourth t minus 30 degrees. Now remember, we always want to deal in cosine, so we're going to change this to a cosine by subtracting 90 degrees from this 30 degrees phase shift. And so what we're left with is 15 cosine 4 times 10 to the fourth t minus 120 degrees. Now we know in order to turn this into the frequency or phasor domain that all we have to do is use that amplitude there and our phase shift, phi. All right, so now that we have our input signal as a phasor, we need to pay attention to putting our resistance and our inductor into its equivalent impedance. So ZR is just going to be R, which is 3 ohms, and ZL is going to be J omega L in the frequency domain, which is just J 4 times 10 to the 4 times L, which is 0.1 times 10 to the negative 3. So we end up with ZL is J4. All right, so now we want to do KVL for this loop here, and that leads us to minus Vs plus I ZR plus I ZL is 0. If I solve for I, it's going to be Vs over ZR plus ZL. Okay, I already know what Vs is. And the combination of the series of ZL and ZR is just going to be 3 plus J4. Now I want that in polar coordinates because it's easier to do multiplication and division in polar coordinates. Okay, so a squared plus b squared equals c squared. So 3 squared plus 4 squared is just going to be 25 square root, which is 5. The angle is the inverse tangent of 4 over 3, which is the imaginary part over the real, which gives you 53.13 degrees. So now that I have that for my bottom expression here, now I want to see what I is. And so I is just going to be 15 over negative 120 degrees over 5, 53.13 degrees. Now I can divide this and subtract that, and I'm just going to get I is equal to 3 at an angle of negative 173.13 degrees. Okay, so knowing I can now solve for VL, which is my voltage across my inductor. So it's still Ohm's law. Okay, so it's just going to be that I times ZL in the frequency domain. So that leads me to 3 negative 173.13 degrees times ZL again, which is 4 times 10 to the fourth. It's 0.1, 10 to the negative 3 times J. Okay, now recall real quick that if we're doing polar coordinates, J is the same thing as 0 plus 1J. So if we're looking at the real and the imaginary axis, J is 0 in the real, 1 in the imaginary, which is equivalent to 90 degrees, right? So this just becomes 12, and then you have negative 173.13 degrees times 90 degrees. All right, so now we can add these, and I come up with 12 negative 83.13 degrees. Now I always want to put VL back into my time domain. So I'll just use amplitude cosine 4 times t to the 4th t minus 83.13 degrees. And that's my answer.